Yes, sir.
Okay. Unfortunately, those that will not be able to join us, I will be recording the call and I'll be posting it on YouTube like I did yesterday, so that those of you that are not able to join or your mates that are not able to join can also follow up on the class and what we did in class. I think that thing is making most of you lazy. Instead of coming to join the class, you would wait later on and then join later. Anyway, I think that flexibility too is good. Um, all right, so without much ado, let's quickly recap what we learned the last time. Can anyone bring us up to speed on what we learned the last time? And fortunately, I hello, please, are you hearing me? Are you on the call? Or you're all
Yes,
doing
please,
some
we are
other
here.
things? You're here.
No, sir, we are here. Yes,
Okay,
sir.
good. So can you bring me up to speed on what we discussed yesterday? Fortunately, I'm receiving your payment and I'm happy. It's in fact I was getting discouraged that you guys were expecting. So I was making up my mind to cancel, the practical things. But
Honorable Malema prepared to chase out Honorable Malema who are protecting the constitution in the name of.
okay, so let's keep on paying. In fact, it pains me some of you are having problems with the internet connectivity at your places. Eugenia has been trying to join and she's not able to. Angela to the same thing. So kindly, let's do well to make payment, by the end of today, so that we can immediately start ordering. I'm hoping that by Saturday we should have ordered the components, and then also those of you that want to purchase your own kits to our allowed. A couple of your mates have indicated, so some of them have even made payments for their own kits individually. And so if you really want to have your own kits for yourself so that later on you play with it personally, it's also allowed. You can also do that. Blaze, is that right?
Yes, please.
Okay.
Yes.
Unfortunately, my camera looks somewhere. We have to we have to manage with it like that. So let's do a quick recap. We can proceed with what we have to do today. What do you remember from yesterday's class? Yes, right.
Sir,
What do you remember from yesterday's class?
all right. So from yesterday's class, I remember that we were dealing with numbers systems,
Number
where
system.
we said human lives in the base 10, which is also called the decimals. And
Okay,
then we try solving some examples where we convert some figures from other bases into base 10.
great.
Yes, sir.
Awesome. That was a very good rundown of what we did in class yesterday. Thank you very much. Yesterday, I met some of your mates, and then they were expressing disappointment at not being able to join the midnight class. So some of them were not able to, and I really felt sorry for them. And it really pained me that they were not able to join. So I'm thinking instead of doing midnight, maybe we should consider doing dawns at 5, especially for this class. Maybe we could move it to 5 a.m. instead of this time. But that is still on a vote. You guys can still vote on it and then let me know what you all think about it.
Okay.
All right. So I think you should let your class rep know so that he's aware of
Okay, sir.
this. Yeah. All right. Who else would weigh in on what we did last time? Yes. Eugenia, you were having problems joining the call. I'm so sorry about your connection. Is it okay now? Hello, Eugenia. Eugenia.
Yes, sir, please. It's okay.
It's okay now. Oh, great. Sorry about that. So I'm coming. I'm trying to. Oh. Yes, who else were in? What was the last thing we did yesterday? Yes, before we left. Yes, Eugenia, what was the last thing you heard before we ended the call yesterday? Do you see my screen?
Yes, sir.
Hello? Okay, you see my
Sir,
screen.
but it's a bit blur.
It's a
It's
bit
not
blur.
clear.
Yes, please.
It's not clear.
Yes, sir.
Yes, sir.
Oh, the internet is very bad this morning. Okay, I'm coming. Let me. The internet is a bit bad this morning. And the network too is not connecting. But these days, MTN's network is very bad. You see, most of the times it comes from how they are designed. Most of the times we just design things the way we like, and it doesn't really help. Okay. Yes. So Eugenia, please, what did you hear from yesterday's class? I'm trying to share my screen. Okay. Let's just do a quick recap before we go ahead.
So we did the representing kilo, mega, giga, and tera in base 2. And then we expressed other numbers in powers of 2.
Okay. That was excellent. Okay, so we also talked about the fact that bytes are discrete, right? You said bytes are discrete. Bytes are not to, we can't have 1.2 bytes. So if you have 1.2 bytes, that means you need to use 2 bytes. Is that right? Then we said you can't have 2.3 bytes, right? You would need to save 3 bytes. So even if it is 2.0000001, you would still need to run it up and then save 3, 3 bytes. Please, do we understand?
Yes, sir.
Great.
Yes, sir.
Now, if so, I don't know. The network is very bad this month. I'm trying to load my board so we can be writing on it. And I don't know why it's taking so long to do. So let's at where we are, our own places. Let's do the following conversions. Can you convert 53 to base 2? Let me see. Then let's see how many bytes will we need to store that number in 53. Can you do that in like 2 minutes? Please, let's be quick on that. What is going on? Oh. think I should have moved to a different department. Okay. Yes, so what will it be? Yes, are you done? Eugenia, today you and I
Yes,
would
sir.
really do this class. The class is for you and I today. Today I'm going to day on you. Is that right? I hope I have the permission to day on you small. Okay, so if you convert 53 base 10 to base 2, what do you have? Yes, have you done it?
Yes, sir. You would have 110,101 base 2.
110
101.
base 2. So how many bytes will we need to represent this number? Hello? Hello? Where is my class? Are they here at all? So when you look at this, how many bits is it made up of? 1, 2, 3, 4, 5, 6.
6 bits.
Right? 6 bits. Is it up to a byte?
Yes, please.
No.
No, sir.
No, it's not up to a byte. Please,
Yes,
we
sir.
understand.
Yes, sir.
So, and I told you that we arrange memory unit in bytes, in units of bytes. That means we arrange them in 8 bits. So this is 6. That means that it's not up to 1 byte. So what we are going to do is that we are going to, you remember how in senior high school, when you write a degree and it's not up to, it's not in 3, for instance, you have 60 degrees. During when we were learning bearing, they told us that you would say 060, right?
Yes.
Good. So the same thing we are going to do here. We are going to do zero. We'll put zeros in front so that we can count 1, 2, 3, 4, 5, 6, 7, 8. Then this becomes 1 byte. Please, we understand.
Yes, sir.
Yes.
Okay. So when I give you a number like um 257, convert it to base 2. I hope you know how to use a calculator to do this kind of thing.
No.
Okay, so those of you with your calculators by you, let's do it quickly. Let me take you through it quick. So go to mode, put your calculator in base 4. That's mode. You press 4. That's base N. Now when you go there, right, you can see that it's naturally in DEC. Please,
Yes.
is that right on your screen?
Yes, sir.
Okay.
Yes, sir.
So if it's in DEC, now when you look at the second line, you can see deck hex bin oct written in green.
Yes, sir.
On the third row of the key, start counting from the top, you can see deck on top of x square. You can see deck, hex, bin, and oct.
Yes, sir.
Now these are the 4 bases we use in computer systems. In computer systems, we actually use 4 bases. We use base 2, base 8, then base 10, then base 8. Sorry, base 16. Now, who can explain to me Who can just give me a reason why we use these 4 bases and no other bases? Eugenia. Eugenia is in trouble. Yeah, Eugenia is in trouble. Today I'm on Eugenia. Yeah. Yes, Eugenia, why are we using base 2, base 8, base 10, and base 16? Why aren't we using base 4? Why aren't we using base 12? Why aren't we using base 20, base 60? Why are we using base 2, base 8, base 10, and base 16? Yes.
I think it's for easier representation.
Why? Yes, I know it's for easier representation, right? But why?
There you see the base 2, it has only 2 factors.
Yeah. If
So,
it even has only 1 factor, 0 is not a factor.
okay. But when you write it in base 2, it's zeros and ones. So
Yeah, it's zeros and ones. Yeah. I like the angle you are pitching in for. That's a very brilliant angle you're taking. That's good. So, yes, Bright, where are you?
So I'm here.
Bright. Yes, Bright. So why
Yeah.
do we do base? Why do we do base 2, base 10, base 8, and base 16? Okay,
I have no idea.
oh, Charlie, with your 3 bullets, pan a Bright at you. Hey, Adiashime. Problem. Okay. So I think you might have forgotten. So let me just go back on it slightly. Okay, so I told you that please pay attention because you meet this in your exams somewhere, maybe in life. Now when we take the powers of 2, 2 raised to the power 2, 2 raised to the power 1, 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, 2 raised to the power 4, 2 raised to the power 5. Right? These are the powers of 2, right?
Yes.
This is equal to what? 1. Eugenia, are you still here?
yes, sir.
Asantewa, where are you?
Please, I'm here.
Me, that name Asantewa, the way I don't like it. Do you know why?
No, please.
As if you are the only Ashanti. So 2 raised to the power 4 would give us 16, right? Then 2 raised to the power 5 would give us what? 32. Now observe something. You see that base, we said we are talking about number bases, right? So base 8, base 16, base 2. Then we just rushed base 10 here because we human beings, we are in base 10. Please, we understand. Hello. Yes, great. So that is why in computer science and computer engineering and electronics and digital systems, we use these 3 bases, which are base 2, base 8, base 10, base 16. So base 2, we shorten it and we call it bin, B-I-N. In fact, in programming, any number that you precede with 0B or 0 capital B is a binary number. I think maybe we should be using this opportunity to learn a little bit of Python on that side. Then base 8, right? Similarly, we are going to write it as OCT. And in programming, we use 0O So you see why I always cancel my zeros. Otherwise, it will confuse you. Angela is really having a very terrible network. I'm sorry about that, Angela. You would have the recording much later. Then in base 10, we have deck. Now, we don't precede a decimal number with anything. Please, we understand, because it's a number. Then we have hex, right? Hex, which is 0x, 0h. Okay, we don't actually use 0h. We always use 0x. And then the x will be small x or capital X. So I write 068A, right? There's a hexadecimal number. If I write 00715 is an octal base. Now, so when you take your calculator, you would see that on the third row, those of you that don't already know this, we have dec, hex, bin, and oct. Now, when you press these, you can see that the number of zeros change on your screen. Is that right? Okay. So we want to convert the number, what was the number of 257 here, base 10, to a certain number in base 16. So what you do is that you type 257, then you press equal to. But be sure that you are in decimal base. So the base you want to you are in, you select that base. So you are in base 10. So you press 257, then you press equal to. When you press equal to, then you go and press the hex key, then it will convert it for you in hexadecimal. When you press the bin key, then it converts it for you to binary. Please, do you understand?
Yes, sir. Very easy.
You are here, right? Hello?
Yes, sir.
Please, you
We are
understand?
here.
Have you been able to follow through?
Yes, sir.
Great.
Yes, please.
Great.
Yes, sir. Very easy.
Great. This is very easy. So now 257 in base 2 is what number? Yes. And how many bytes? How many bits is it? Yes. Can you count for me?
Zeros.
Come again.
2, 5, 4, 7, 8, 9, 10, 11.
So when you look at it, there are nine bits, right? So we have.
Yes, sir.
So we always start counting from the back. We always start counting
Okay.
from behind. So 1, 0, 0, 0. Let's arrange it in fours so we can easily count. Then we have 0, 0, 0, 0.
1.
Then we have 1. Please, we understand.
Yes.
So
Yes, sir.
this is equal to 9 bits, right? Now, if we want to store it in a memory unit, in fact, we call memory units registers. Where we store these numbers, we call them registers. 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 Now, and I told you that registers are arranged in bytes, right? Memories where we store numbers, they are arranged in bytes. So if we have 9 bits, how many bytes will we need?
1.
2.
Who
That's
said
the
2?
zeros.
1.
I heard a lady's voice. Was it Asantewa?
No, sir.
I have to start giving marks for those that talk in my class. So I really need to start noting you guys down. Please, who said 2? The lady
Please,
that
me.
said 2. Asantewa.
No, sir. I said
Your name, please. I'm not seeing your name. Esther. Esther, excellent. So is it 2 or 1?
1.
2.
So why 1 and why 2? The guy who is saying 1, Bright, you are saying 1. Why 1?
So having said 1, is other guy.
Oh, okay, another guy. Please, another guy. Why did you say 1? But so we all agree he's not 1, right? You see, the other guy is not even able to defend. So he himself has seen is not 1, right? So you can't store
I think
9 bits in 8 spaces.
Yes.
So what happens to the 1 here? So are you going to throw it away? No. So we would store it in a 2-byte area. Yes, Samuel. Samuel, your hands is up. So we are going to store this number in a 2-byte area. Is that right?
Hello,
Now, yes, Sammy.
Hello.
Sammy, please. Yes, Sammy, you have the mic. Please talk.
Hello, sir.
Sammy, I'm hearing you. Are you hearing me?
No, sir.
Oh, okay. So the mic is yours. Please talk.
Hello, sir.
Sammy?
Hello, sir.
Yes. Hello, Samuel. Samuel, we are hearing you.
Hello.
Okay. I think Sammy is having some problem with his network. Someone should text him in the chat for me. So please, do we all see what I've written here? So all of this is 1 byte. All of this too is what? Another byte. So that we would now need 2 bytes to store this number. Please, do we understand?
Yes.
Now, you see how we are wasting 7 bits. When you look at it, you can see that we are wasting 7 bits, right? Yeah, but that is how we maintain reliability. Please, do we understand? So if I ask you this question, if I ask you a question and I say, how many bytes will be needed to store the number 3,271? Eugenia, what will you tell me? Hey, you're not the metal, so yes. So how many bytes will you need to store? Please, you're on the hot mic. I think you should mute yourself before you tell us something you don't want us to hear. So how many bytes will be needed to store the number 3,271? Yes.
2.
Yes, Esther.
Sir, please, I think 2 bytes.
2 bytes can store the number 3,271.
Yes, sir.
Are you very sure? First of all, let's use our calculator to convert it. 3,271 in decimal. Let's take it to bytes. To binary. Please, when you convert it to binary, what is it on your calculators? Yes. Let's start counting from the LSB. We always start counting from the LSB. So let's start counting from the LSB. Yes. 1 1
0 0 0.
1 1 1 0.
No,
Why?
110.
So we are starting from the LSB. We always start writing from the left. We start writing from the right to the left. Please, do we understand?
Yes,
Yes.
sir. Okay.
Good. Do you know why we do that? because we are counting them, we are arranging them in 8. If you start counting them from the left, you won't be able to arrange them well. Please, do we get
Yes, sir.
it?
Yes.
Okay, so we start writing from behind. So we have 1 1 0
0
0
0
1
0.
1
1
1
1
So 0 0 1 1
0 0
0
0 0
1
1
1
1
1 1.
1 1.
So
0 That's
so
all.
we have
0.
this is 1 byte, right? Please, you understand?
Yes.
Hello.
Yes, sir.
Yes, so I think Esther was right. It was actually um 2 bytes. Esther, well done. Okay. Now, if I
Yes,
give you
sir.
a big number like, 17 million, then I say how many bytes can store it? What will you write? How will you find it out?
17.
Yes, 70 million.
They get error.
Yes, you see that the calculator is not able to do it for you because the size is big.
Yes.
So yeah, so if you are converting it, hello,
Sir,
he said
it's
it's
error.
what 3 bytes. Can you please walk us through how you got your 3 bytes? Hello,
4 bytes. Yeah.
Charlie, obi ni me to chacha or class you mu pa. Hey,
It's error.
so 17. The reason why the calculator is telling you error is because it's beyond what it has been calculated for. You see, it tells you mass error, so it's beyond what it has been calculated for. But then, so this is 1 byte. Then we will fix 4 zeros in front. Then this becomes the second byte, another byte. So that in all we can put them in what 2 bytes. Now, if I give you 17 million, if I give you 17 million, what we have is that 17 times 10 exponent 6. If you want to find the number of bytes it can hold, there is a secret I'm going to show you. And the secret is this. It's very, very important you know this. Log 2 raised to the power. So 2 to what number? 2 to the power what will give you 17 million? What will we get? Log 2 to the power 17 million. We'll give you how many years?
24.0.
24.0190 bytes. But is this correct?
No, please.
So how many bytes?
25.
25. 25 bytes. Please, we understand.
Yes.
Great. So in the exams, in your objective, I can be asking these questions. I can ask you how many bytes will be needed to store this. But then in memory units, we arrange memory units in powers of 2. Is there any memory unit that is 25? Is 25 a power of 2?
No.
No. So we wouldn't have any memory units that's 25 bytes. So what you have is you have 1 byte, which is true or false. For instance, in programming C++, true or false is a 1 byte, data. Then the car is a 1 byte data, right? Car is a 1 byte data. ASCII, encoding for ASCII. Then we have a 2 byte data. We have them there. We have 2 bytes data, which is integer. That one we call it. Yes, Angela. uint HT is a 2 byte data, right? So yes, Angela, you have a question, eh? So in programming, we don't have 25. All the memory units are arranged in powers of 2. So when you get 25, that means that it's bigger than 16. So you would use what? 32 bits. Is that right? 32 bytes, right? So you would find a register that can take 32 bytes, or you would allocate 32 bytes to store that number, even though you just want to store 17 million. Please, we understand.
Good, sir.
So when you get 25 bytes, 25 bytes is correct, but memory units are not arranged in any number apart from powers of 2. So for instance, your data type, assuming you want to store 17 million, so you found it was 25 bytes. There is no data type that is 25 bytes long. All the data types, for instance, you have bool, right? Boolean. So you have bool here, car here, which is 1. Then you have integer here. All these are integers. In fact, these ones you can specify. You can say uint 8 underscore t. 8 stands for the number of bits, right? So 8 bits means 2 bytes. You can have uint so sorry, uint 8 is actually 1 byte. It's actually 1 byte because 8 bits is 1 byte. Then you can have uint 16 underscore t, which is 2 bytes. You can have uint 32 underscore t, which is actually 4 bytes. Then you can have uint 64 underscore. So we count it this way, right? So assuming you want to store 17 million, the number of bytes you need is actually 25. But you can't store it. You can't declare a variable that is 25 bytes long, right? So you need to find one that is originally designed in the standard basis that we know. Please, do we understand? So always, when you get your numbers, make sure you choose the nearest bigger power of 2 for your analysis. If you get it in the objective, don't just choose 25. 25 bytes will be correct, but in actual practical implementation, you will never get 25 bytes register. You would always get 16 and 32 bytes. So you would actually choose the 32 bytes register. Please, do we understand?
Yes, sir.
Okay, great. Please, any question? Yes, Gideon.
Please, about the bits and the byte. The
Yes.
17 million, are we getting the 25 bits or 25 bytes? Because it's confusing me.
So, thank you very much for pointing it out. So it's actually 25 bits. Thank you very much. Please, do we all agree? Hello.
Hi.
Please, do we all agree? It's actually 25 bits, right? So show me by your thumbs up so I see that you're here. Just be reacting. Don't forget to react. right? So it's actually 25 bits. Then you can convert to bytes, right? Great, great. Thank you very much, Gideon, for pointing it out. That means you guys are really understanding what I'm teaching, and I'm very glad that you understand. Very, very, very glad. Okay. Now, before we end today's class, I think we started at 8:30 something, 8:25 something. So let's say 9:25, then we are done. Now let's do. I know you've done this in senior high school, so we don't really need to waste a lot of time on it. Addition of number bases. Let's just quickly run through it. If I give you a number like 1011, so at the end of this class, I'll be giving you a lot of assignments on what we've done here, a lot of them, so that you would go and then write it. You wouldn't print. Now I'll copy it. Okay, so if we are adding these, how would it look like, right? 1 plus 1 will give us what? Yes, 1 plus 1 is what? We are doing this addition in base 2. So 1 plus 1 is what?
10.
Hello?
2. 2 said.
0.
So one,
0.
oh, so you're not even seeing my screen. Sorry. It's taking time to refresh. Okay, so we are giving this number to add in base 2. 1 plus 1, right? Over here will give us 0 remainder 1, right?
Yes, sir.
Good.
Yes,
Then
sir.
this one, we add it to this 0. So we have what? 1. Then 1 plus 1 will be another what? 0 remainder 1. Is that right? Then this one will be added to this one. Then we have 1 0. So another one here. So 0 plus 1 will give us 1. Then that one will be added to this one here. Right? So we would have 0 remainder 1. Then that one will come here. Then 1 plus 1 will give us 1 0. Please, we understand.
Yes, sir.
My board is not updating in real time. So you're not seeing what I'm writing. So when I write it, just follow. When I write it on the screen, just follow. So that you can be practicing it even before my screen update. Please, someone is giving us feedback. Okay, so that is that. Let's try this. Please try this for me. I'm writing it on the screen. Let me read it out. 1 0. Are you ready? 1 0 1 1 1 1 0 1 plus. So 1 0 4 ones, then 0 1 plus 1 1 0 0 1 1 0 1. So you have 1 1 1 0 0 1 1 0 1. So the first one, the link is very slow, so it's taking time to update. So you can write it on your screen and then practice it and tell me the answer. Do it and tell me the answer. Yes. So what will it be?
Please, in which base?
Base 2. We are in base 2. So yes, the addition has now shown on the screen. So what will it be? Yes, please do it quick. Don't use a calculator. Just try working on it on your own to understand the principles. Don't use a calculator.
One.
Somebody said it is 1 1 1 1
0 0 0.
0 0 0 3 zeros.
Yes, sir.
1 0 1 0.
1 0 1 0.
1 0 1 0. Is that what you all
1
got?
0.
Yes.
Yes,
Yes,
sir.
sir.
Great. Esther, did you get that?
Yes, sir.
Great. Asantewa, did you get that? Asantewa didn't get that. Okay. All right. So that is that for addition. That's correct. Well done. Now, what if we have, subtraction? 1 0 1 1 0 1 minus 1 0 0 1 1 1. We are subtracting this. What will it be? In base 2. Yes. Will you try?
Can you take it again?
So it is now, it has updated on the screen. So just write what is on the screen and try it. The network is up and down. Now it's good. You can see it. Christodia, are you on the call? Christodia Boantima, are you on the call? I saw Christodia join the call. Where has she gone to? Okay, so Junior, what answer did you get? Yes.
0 0 0 1 1 0.
0 0 0 1 1 0. Asantua, is this correct? Asantua, tell me she's wrong. Isn't she wrong?
Hello.
Asantua, isn't she wrong?
Yes.
Is she correct?
Yes. No,
You see, you were not doing it. You see, I caught you. I've caught you like that. Okay, no problem. The next question is for you, so please prepare. Is that right? Angela, is it correct?
Okay.
Angela,
Sir,
is it correct?
I don't really know.
That means you were not trying, you were not following it. Okay, Sammy, is it correct?
So it's not correct.
What did you get?
0 1 1 1 0 1 1 1 1.
Wow. Okay, then let's solve it, the whole class. To clear all doubts, let's solve it. So let's all solve it. Hello.
Yes, sir.
Yes, so let's solve it, right? So 1 minus 1 is 0. 0 minus 1 is not possible. So we are going to borrow this one. Then when we borrow this one, here will be 0. 0. So here will be 0. Then that one that we've borrowed would be here. But that one will actually be what? 2.
2.
Because we are in base 2, if we borrow anyone, it's actually 2. So that will be 2. Then that 2 that we have here, we can subtract 1 from it, and we will get 1.
Mm-hmm.
Then we will come here, and here is 0, because we borrowed the 1. So we go and borrow this 1. Then we will bring it. Then here will become 2. Right? Then we will subtract this 1 from the 2, and here will become what? 1.
1.
Now we borrow this 1, so here is 0. Right? So 0 minus 0 will be 0. 0 minus 0 will be 0. 1 minus 1 will be 0. So I think Eugenia was correct. Eugenia, well done.
Thank you.
Great. Please, do we understand? Let's try one other
Yes.
one
Yes,
so that
sir.
we can understand the concept. So we have 1 0 1 0 1 1 0 1. Then let's subtract it from 1 1 0 0 1 0 1 1. What will this be? Yes. Please, those on the hot mic, you just mute yourself. Don't distract us. Yeah, so what did you get? As until I told you that this next question is for you. This one is a gift for the only Ashanti girl in the call. Asantewa. Nana ya Asantewa Abakope. Please talk. I'm hearing you. Yes. What will it be?
Sir, please, it will be.
Uh-huh. Oh, you are not done?
No, I'm not done.
Okay. All right. So let me give you 1 more minute. Angela. Angela, are you done?
Zero.
Hey, who is that? Okay, Emmanuel, you want to try? Let's go. Yes, Emmanuel, what did you get? Yes. Angela. Angela, let's go.
Sir,
Uh-huh. What did you get? Call out your numbers. We are starting from the LSB, least significant bit. So call them out, yes.
0
0
1 0 0
0 1 0 0
0 1
0 1
yeah. Sir,
this
another one, and then minus.
another one, then minus. So this is Angela. Yes, thank
Sir,
you very much.
wow.
Nancy. Nancy, please, can you unmute and let us have you? Nancy. Oh, okay, Emmanuel. Yes, Emmanuel, let's go. Nancy is having network.
Okay, so it's
0
0.
1.
So you had 0 1.
0 0.
Please increase your voice. 0 0
0
0
1 1.
1 1. Is that all?
1 1 0.
Come again, please. I'm not hearing the last part. 1 1.
0.
Okay, 1 1 0. Negative or positive?
Negative.
Negative. That's Emmanuel's submission.
Say
Is that
it's the same answer.
Emmanuel?
Hmm.
Okay, let's try it. Let's try it. Let's all try it and see what it is, if it is it. 1 minus 1 will give us what? 0 here. Is that right? Asantiwa, please, I'm doing this with you. So just look up and follow for me. Then the next bit, the next LSB, the second LSB on the top is 0. So we call that the minuend. So this is the minuend. Right? And this is the subtrahend. Subtrahend. Okay. So the minuend is 0, the subtrahend is 1. So we are going to borrow this 1. Right? So when we borrow here becomes 0. Then here becomes 2. So 2 minus 1 becomes 1. Then here is 0. So 0 minus 0 is 0. Then 1 minus 1 is what? 0. 0 minus 0 is 0. 1 minus 0 is 1. Then here is 0. So we are going to borrow this 1 here. So when we borrow it, here will be 0. Then here will be 2. Then we are going to have 1. Then here would be 0 minus 1, which is not possible. So we are going to borrow from somewhere and then bring it. Then here will be 2. Now, because we are borrowing from somewhere, that's where we get minus. So this is 2. So we borrow, then become 1. So there'll be 3 ones minus 1. Please, do we understand?
Yes, please.
Great.
Yes, sir. Yes, sir.
So that is how we perform operations. Yes, Esther, your hand is up.
But the calculator is giving us a different answer.
Yes, it will give you a different answer because it's minus.
Okay.
Yes, so it uses something we call two's complement. We will get to it very soon, so you would understand why. But then what you can do would be to so when we get to the two's complement, you would understand why it works the way it does. Please, do we understand?
Yes, please.
Yes, sir.
Now, let's move on. No, I don't think this answer we have is correct. So let's try this thing. We might have messed something up. Now we know that in math, A minus B is the same thing as B minus A negated, right? So if we have this, let's change. You see, obviously the second one is bigger. The second one is bigger than the top one. So let's subtract the top one from the second one. Then negate the answers. Please, do we get it? So let's subtract the top one from the the down one from the top one, so that we have 1 1 0 0 1 0 1 1 minus 1 0 1 0 1 1 0 1. So let's do this together, right? And so we have 1 minus 1 is what? 0. 1 minus 0 is 1. 0 minus 1.
How possible we borrow?
Yes, we are going to borrow. And then here becomes 2. So 2 minus 1 is 1. Then here is 0. So 0 minus 1 is not possible, right?
Yes.
Please, are we following?
Yes.
Yes, so we are going to borrow from this one. It's not possible. We are going to borrow from this. It's not possible. So we come and borrow this one. So when we come and borrow it, this one is now 0. Then here would be 2. Then we will come and borrow, 1 from these two, so that here will be 1, because we borrowed 1 from these two. This is 2, so we borrow 1. Sorry, the 1 that we've borrowed becomes, then we bring it here, so that we have 2. 2 minus 1 will give us what? 1. Please, if you understand. So what we
Yes.
borrowed, that 1 that we borrowed, we took all of it, so here became 0 again. And then that 2 that came here, we took all of it here, so here became 0 again. Then here became 2, then we took 1 from it. Now, so when we come here is 0, 0. Is that right?
Yes.
Then here 2 is 0. So we have to borrow another 1 again. So we will come here, come and take this 1. This 1 here. And then when we take this 1, let me erase something so that there will be a little there. So subtraction in number basis can be a little bit confusing at times. So you have to be practicing a lot so that you can get a good handle on it. Okay. So we are done with all of this. Now, when we were doing it at first, we took this 1. So this 1 is now 0. Here is now 0. Is that right?
Yes, sir.
Yeah. So here is now 0. We took this 1. So here is 0. We can't take from it again. So we are going to now take this 1. And then when we take this 1, here becomes 2. Then we come and take from it. So it becomes 0. Then here becomes 2. Then we can now subtract our 1 here. Now here is 0. So 0. Then Charlie, I'm confusing myself.
Yeah,
Sir,
you
please,
made
there
a
was a
mistake
little
somewhere.
mistake.
I think I've made it long. Yes, I'm confused.
Yeah,
Yeah,
you made a
there's a
mistake.
mistake. There was a
I
mistake.
made a
Made a
mistake.
mistake, sir.
Oh, and you are
Yeah.
pointing it out to me. Charlie, you guys don't like my matter at all. You want to laugh at me. Emmanuel.
Oh, no.
Yeah, Emmanuel is having his hands up. Okay, Emmanuel, what is it? Yeah, Emmanuel. Yeah, do you want to say something? Okay, you know what? So let's just go and practice this one. Is that right? I don't know why my phone has, because the time is almost up. Yes, Momoni, Emmanuel, please talk. Any of you can unmute and talk. Yes, Emmanuel.
Sir, yes, sir.
Yeah, please talk. Let me hear you.
So,
Sir.
the 0. Okay, so for me, I'm getting 1 after the three ones, the 0 there. I'm getting 1 there, not 0, not 0.
I think I might have missed a step like you have rightly pointed out. And I think what you're saying is true. I myself have seen that I've missed a step, but going to work it out again. I'm feeling lazy right now. So long story short, me. Great.
Okay,
So, but
yes,
it shows me that you really understand it, and I'm very, very glad. And I'll be giving a couple of assignments so that you can be practicing more on this to understand it well. Yes, please talk. All of you that have raised your hands, I want you to talk before we end the call. Gideon, let me have your submission.
Okay, sir. So you see, the second one.
Yes.
the top one, where the second one is, we can borrow one from there directly and spread it across all the zeros.
Yes. I think that was where I did. I think that was where I did the error. Right.
Foolish.
Yeah. Okay. Thank you very
Hello,
much.
sir.
Yes. Emmanuel, please talk.
So when you borrow one, you can spread it across that top zeros there so that they will all become one. Then you subtract it, then you get the answer from D.
I think that was where I got it wrong. I can I can spread it. I was confused myself.
So my
So please solve it, and then let me have it. Let me have it as part of the assignment. I'll be sending the assignment shortly. But then you have to submit the assignment on official sheets. You are not to print it, type it out, because this is plenty. If you want to type, it will be long. So just submit it on official sheets for me. Please, do we understand?
Yes, please.
Okay. All right. So guys, thank you very much for
Yes,
joining
sir.
me. Thank you
Thank you,
very
sir.
much.
Question.
Thank, thank you.
Thank you, sir.
So enjoy your weekend.
Thank
Yeah?
you, sir.
Sir.
Yes, and don't
Okay,
forget
sir.
to
thank you, sir.
good. And
God
don't
bless you,
forget
sir.
Amen. Amen.
See you in
As for
class.
blessings, I will take it. But
God
thanks it
bless you,
belongs
sir.
to God. Yes, I like God bless you more than thank you. Yeah. All right.
Then
God
God
bless
bless you,
Jamal, you
you.
want
sir.
to say something before we go? Jamal, you want to say something?
Yes,
Okay.
sir.
Yeah, Jamal, let me hear your submission.
Because one left the group.
Okay. So I think the network is not good on his side, but you can still test me, if you want to still have a submission. Yeah. Okay. Do have a very good day and a very good weekend. Bye-bye.
Bye, sir.
Same to you and bye, sir.